Hello, welcome to another lecture in the Python and SQL series. So today we are going to be working on something very interesting, object-oriented programming. So without much ado, let's get into it. Okay, what is object-oriented programming? We have started with variables, functions. We completed data structures. And the next level is object-oriented programming, where we are going to be studying classes. Main thing is classes in Python. That's the higher level we are going to go into to understand what are classes. In Python, everything is objects. Okay, classes are a combination of we have data structures, variables, methods, all in this particular object that can perform different things on these data sets. In this single object has all those things that we learned in the beginning that has it as part of it. So we have just that object that have all the things that we studied so far up to data structures. So that's what we are going to go into today. So at the end of this, we should be know what is class, what are classes, and the attributes and the methods that the classes can have. We understand the init. We will go into inheritance, polymorphism, encapsulation, and composition. As those are some part of things that you can do with a class. You should be able to write object-oriented programming. A lot of people do not really know much about object-oriented programming, but as an engineer, it is expected to write a code that is very reusable, and object-oriented programming is where you learn that concept. So that is where we need to understand object-oriented programming. Apart from just functional or procedural programming, this is very important for every engineer to understand what is how to represent things in the real world with classes. Okay, now let's go into what are classes. A class, so a class is here. It's a blueprint. You create a blueprint of something. For example, a dog class. So what what is the blueprint print for a dog? So that's the class of a dog. You can have a class for a vehicle or a car or a robot, whatever it is. It's a blueprint you have created, so that if you want to create an instance of that blueprint, you just call that blueprint and give it things that will give you an instance of it. So a class is a blueprint, and you can create an object or an instance of that particular class. So let's look at the dog class, like a dog, right? So you said you use the keyword class, then the name of the class. Okay. Now you go into the class. We have different methods that can go in a class, but one of the most important one is the init method. Okay, the init method here. It takes self. Self means is pointing to me, self. So an instance of the class self. That is, just understand the self is pointing to that instance. If you create an instance of that class, that is pointing to it. The self pointing to it. So the init class, okay, the init method in the class takes it's pointing to me self, and then you define whatever parameters or attributes that the class, like an instance, can have. So let's say a dog, an instance can have a name and the age. Okay, the instance can have a name and an age. Okay, now if I say, okay, let me just go and then create a name. If I take the name and the age, if I'm creating an instance, I'll assign it to the variables name, age. Okay, I'll assign it to those variables name, age. So I say self pointing to me dot the name variable, my name equal to the name that I received when I'm creating the class, and then me self dot age, the instance equals the age that I received when we are creating this instance. So if you have the init class, it can come that you have to provide it some starting variables. It can also be that we don't, if your class doesn't need an instantiator to have variables, yeah. So this will just be empty. It will not have any other variable. It will have the self, but it will not have anything. But if your instances will have some variables, yeah. So a name and an age, you have to pass it to the constructor like this when you create this method. So self name is name, self age is this, okay? That is the this method is like it comes with the class, and that is what you use to create an instance of the class. That is the init method. Then you can have any other methods that you want your class dog to have. For example, right? So these are called instance method. A speak is a behavior or a method for a dog, and you are saying that okay, the speak self to mean like mean the instance that you have. If I call this method to speak, it should say okay, you see return myself dot name, the self dot name, see self dot name says woof, that's the dog barking, but this is a method you created for the dog class. So here is a method for the class, but this one is the instantiator, is the constructor for the class. So you don't call this one, this is something comes with the class, but you call this one to do something for you. So for example, yeah, over here, okay, we want to create an instance of the dog class. Okay, to create an instance of the dog class, we say Fido, that's the name of this instance we are creating. Then we call the class, see the class, we put into brackets here. Then we put the required parameters, or yeah, the required parameters to instantiate that class. Okay, here we are saying it's name and age. So we put the bracket and put the name first and then the age. We see we just called the dog class. We did not call anything in it. We just called the dog class. And then into bracket, we provided the name that is needed in here and then the age. Okay. Then this will create an instance of this dog class. Once you have the dog class, this instance now have all the properties. It can speak. Okay, it can do whatever this class. So far we have only speak. So if you create the instance, okay, let's run this part first. Okay, and then we go here, we run it. Okay, so Fido is created. When I say Fido.speak, you see that it's saying Fido says wolf. Is the speak method for the class is being written here. Say self.name. That is the name now is Fido. So Fido says wolf. So let's create another instance. This dog, his name is Kofi. Okay. So Kofi equals dog, the class name, and then the name Kofi, and then the age is 5. Okay. Now if I say print Kofi.speak, now you see here, now it's a Kofi says wolf. So you see that we have one object that has all this stuff. We can create different instances with different names, and then it will be able to call different methods that are defined in this single object. So you see this single class object has different things in here can be used by an instance. So any instance that is created out of it. So I want to look at variables. You see the variables we are using like self.name, and then there are different ways you can create. Let's look at it. So what instance variables, we learn variables. So variables are there in class, and also we learn regular variables, okay? So if we have the class, so let's take a look at it. If we have the class dog, is there, right? Now, we create, you see, this is the class. We create something outside. We didn't put it in this, we put it outside. You see, species equals canis familiaris. Okay. That is a class variable because it's outside any method or constructor in the class. So it is a class variable. It's defined at the class level. Okay. Now, if we go to the constructor for the class, right? Self name. This is the constructor. This here, this self dot name equals this. This is an instance variable. Why? Because this belongs to an instance. It belongs to a particular instance. It's not for the entire class. It's for any instance. So, for example, so because of that, if you say Buddy is a dog, okay, and his name is Buddy, okay, Lucy is also a dog, and his name is Lucy. Now, if I print Buddy dot species, okay, you see that if I let me run this one. Okay. If I print body.species, it's going to print the class variable bodies, you see. If I also print Lucy.species, it's also going to print the class variable. You see that? So that class variable is available to all the instances. Okay. But what happened if we now change, if we change the class, you see this class variable, let's change it to, it was this, then we change it to good boy. This is the new class variable. The moment we change this to good boy, now if you print bodies dot species and Lucy, they all print because the class variable is updated in everything. Okay. Okay, now let's change something. Let's go and change the instance variable here for one person and see. So here we are saying we are changing the name, which is the instance variable for body, right? So we change body dot name equals Buddy the dog. Now, if we print now Buddy the dog, that's the new name. Yeah, that's the new name. But Lucy still the same Lucy because that is the instance. It's the instance variable is affecting only Buddy and not Lucy. So that's how you can differentiate between what is an instance variable and what is a class variable. Class variable is defined at the class level, but the instance variable is defined within the the constructor, the initiation point of the class. Those are the variables defined inside the initiate creator for the class. Okay. Now, I want to also talk about the methods that we have in the for class. Okay, there are different type of methods: instance methods, class methods, and static methods. So I want to talk about these three things. How do we add them? So instance methods are just, you see, all these define the methods that any method that you define as an action that can be performed inside, and it will have self. Okay, first before it points to the self. Okay, the self, it points to it. Okay, it points to myself as the instance, and then if there's any parameters, it will take it. So instance variable will always have self, and then it will have other parameters that the self instance needs to have. But so this is an instance variable, and this constructor is also is this particular thing is, so this is a class robot. Okay, so a class robot, defining a robot class, and I define a class variable population equals 0. And this is the constructor for the class. Okay, all right. You see, the constructor is for the self. It's also for only self. It will have self, and then have a introduce yourself as one of the classes, one of the methods for the class. You see, it takes self. It's for that instance, so it's an instance method. It works only it's only for that instance. The instance can operate on it. Okay, it affects only that instance. Everything you are doing is affecting that instance. Okay, so if you want to access, you see, all these instance variables, the instance variables that are defined in the init, right? You use the self dot the name of the variable. Okay, so that's where the instance methods will have the self, so that it will be able to point to the instance variables. Okay, to be point to the instance variable. So this is the class robot. It has a class robot. It has population. So in the initiation, the instance variable is name is given this. Then there is one. So let me now talk about what is a class method. Okay, so this one here. Okay, it is defined with the decorator at class method. At class method in the top. These are called decorator. If you see the app and then the thing is called decorator. So decorator, to classify a method that is in the class as a class method, you have to put the class method decorator at the top. Then you will define the method and then you pass CLS. CLS means class. That's what you're going to pass to that method. So when you pass CLS to that method, it will now have access to all the class methods, I mean the class variables. So you see, this is the class variable. It will act on it. It will update. Like in this case, I'm just trying to update the population. It was 0. It will add 1 to this population. Okay. So my goal is this. Anytime I create a new robot, I want to increase the population of the robot, the entire robot, to 1. Okay, so this class method is what is updating this population count for me in this situation. And because it's a class method, it was able to accessed this one and then increase the population by 1. Okay, it increased the population by 1, and we define the class method by putting the at class method of decorator, and then we pass in CLS to this type of methods. Okay, for instance, we pass self to the instance methods. Okay, and then if to access the this one here, we say cls dot population. Whatever you pass to it, it says cls means the class. That's the Python is interpreting it. Cls means the class. So cls dot the population will be this population. It increases by 1. So what this does is, if you create, anytime you create an instance of this class, it will increase the population of the robot by 1. Okay, but this method, the instance method, anytime you call it that introduce yourself, it will just say, hey, I am like whatever robot it is. I am robot A, or I'm a robot B. That is an instance method. Okay, right now then there's another method you can another type of method that you can provide for a class is a static method. It's like a utility function in that particular class. Okay, it can be doing anything. It doesn't have to be working on anything like the data or the variables that are in the class. It's just a function that provides some utility for the class. Okay, it's a method that provides some. Like look at this, for example, right? So you put the decorator at static method to say that this is a utility function. It doesn't have to do anything with the data in the class. It's just to provide some functionality for the class. So like this, for example, this one, right, is valid name. It takes a name, anything name string, you give it to it. It return if the length of the name is greater than 0. It means if you actually have something in the name, and then the name is alpha, is alphabet, then it will tell you, yeah, true. Yes, it will return that. It's that one. It will check to see if it is a string. Yeah, then to say yes, it's valid name. It doesn't care about whatever it is, just a functionality to check something, and is provided as part of a service for the class. Okay, so that one is given with a static method. Okay, now so let's see this one. So you see, we have these classes. Now we are creating an instance of a robot. So it's Roomba or Roomba, whatever it is. So you put the name of the class. This is the name of the class, and then it says that to initiate a copy of it, you need to provide name argument, the parameter, right? So we give it name. So we give it name, right? So we have Roomba now. So now Roomba has all the capabilities that is defined for introduce itself. So we say Roomba.introduce you is going to call this function. And this function, when you call it, you see it's going to print me, I am Roomba. So when we run this, that's why it says, first one, it says I am Roomba, because it's calling the introduce. The introduce is going to print my name, I am Roomba. Now, look at the population. Okay, we want to see what is the population after Roomba runs. See, we created Roomba now, so we have first robot. Okay, it's in there. So we check the robot population. You see, the robot population is 1. Okay, right. We check Roomba. If you check the population from robot or from the instance, Roomba is the same because Roomba is just showing the population that entire robots have. Okay, that's all it is. Now, let's say room. You can use the robot, the class, to check anything because it's just a functionality for the class. So if we write that the robot class dot is valid named Roomba, it's true because that is just a functionality provided by static utility function here. And also from Roomba instance, also you can use the same utility function to do anything, right? It's just checking those. So that's why you're able to call from the robot class or from an instance. You can access the both the static method. Okay. Now, let's go to that's the static method. What about the class method? The class method here, okay? We can access this from both the also from both the robots. We say, okay, so that robot, the class robot, we are calling now the static method increase population. We are just directly saying, hey, increase the population. So what is it going to do? It's going to increase the population of robots by one. So let's do that and then see. Yeah, it's by one. It was one, so we increase it to. So if we run it again, if we run this again, it will increase it again. So you see now population is now 3. If you run this class again, if you just run it again, it will keep increasing. So it's increasing the population. Okay, so that is using the class name dot increase population. That's using the class name. But also we can use the instance, okay, the instance Roomba to also increase the population of robot. Okay, it can also call the class method. So let's say, so it's 4 here. Now if we run it again, now we call Roomba dot increase population. What happened? That instance is able to access the class variable population using that class method, using this class method, and increase the population. So let's say there's another robot. We say this robot is avatar, and we say, hey, increase yourself. So it was 5 here. The moment we now create another robot, you see that the population is 6, and everybody will now have the new population. Population is 6. Okay, avatar has also population 6. We ask Roomba, what is your population? So it's updated across the entire thing. Okay, that is something that we want to. So for class variables, and then we have class methods. The class method can cause the entire thing to be updated for the class, and every instance will get the updated value. So that we should remember that. Okay. All right. Another important thing in object-oriented programming is encapsulation. Okay, so think about it. You have code that is there, okay, that is working behind the scene of a lot of utilities that, take for example, the remotes that we use for the TV, turning the volume up and down, right? There are functionalities in that remote, but you don't know how it works. You just press the up button, and by magic, the TV goes up. You press the down button, and the TV goes down. You don't know, you don't have to open the wire to see how it's working behind the scene. Okay, that concept of hiding those things and bothering those things and create a way for these things to be in a single thing that somebody don't have to know the details to know how to use it. It's called encapsulation. Okay, so it's a practice of bundling data, the attributes, the methods, everything that work in a class, in everything into a single object, and then you're hiding the internal working from from the outside world. Like if you're using the remote, you don't know how the wiring, everything, you're just pressing the button, so it's hidden. And to do that, Python provide ways that we can do the encapsulation. Okay, there are simple conversions that we use in Python to do that. Okay, we'll take an example. Example is always better for these things. So I put here name. Look at this, one underscore, double underscore name. Just take about it like this. Okay, look at that, but let's go here so that it will make sense with an example. Now, I am creating the class for bank account. Okay, I'm creating a bank account class, and I say, okay, if I'm creating an an instance for the bank account. Like if I want to create a bank account, an instance of my account, I need to know the deposit, like how much you want to deposit, and then your social security. Okay, that is the constructor for this class. Okay, you need to provide me the balance the person is going to deposit, and then also the person's social security. Okay, I'm saying that in this bank account, the balance called, see the underscore, self dot underscore balance equals the balance that the person they provided when they're constructing the account. And I put underscore before the balance. That makes the balance something we call it internal data. It's like we don't want to, you can access it, but we don't want you to be access this because we want to provide another way for you to safely check this, because we could quickly change the entire of this variable without telling you. So it's for internal use. Okay, we don't want you to be directly accessing it. Okay, you can access it, but we are telling you that if you are directly accessing this directly, you are like you're opening the remote to take the wires and see, okay, this one does this, that's what you pull it to get the volume up, and that you are going to be screwed if we change it. So we don't want you to use the variable underscore balance, because it's for our internal purposes, for the remote to work. Okay, now another one like the social security. Okay, this social security we have here. Okay, we put double underscore social security they gave us. We put double underscore before the social security number. If we put double underscore before the social security number, we are saying it's strictly private. Okay, you cannot access it directly with dash underscore double underscore the social security number. We are saying it's private. You cannot access it like that. Okay, all right. That is something we are describing that, hey, this is not open to the outside world. We might provide something for you to read it, but we don't want to. You cannot directly call that variable and get the name. That's just how it is that we are implemented it. Okay, so now, as I said, we've hidden these things behind the scene, the social security behind the scene, the wires are hidden behind the scene, but how will the people be able to work it? So that's the remote, the buttons. Okay, so we are providing what we say that in Python we have getters. In programming, there are getters and setters. If you have variables, you have something to set them up, something to get the value of them. We call getters and setters. Okay, so we say, okay, we are going to provide an interface for you to be able to look at the balance without directly going to check for the variable underscore balance. Okay, and that we have a decorator. The recommendation is to use this decorator property instead of using dash balance or whatever it is. Use the properties decorator. The property decorator provides you an interface so that you can define how to get the value of the balance. Okay, so you provide at property. Okay, then you say define like a function or a method, then the variable name balance. Okay, and then self. Okay, that's the balance is the this variable balance. Okay, then you say self. It's a self instance method. So this, in this balance, when you ask for this balance, okay, internally, then we are going to return for you, okay, the value of what is the self dot bal underscore balance, and we want to return it to you in a format. For example, this format means that, hey, we are going to give the balance and we are going to add 2 decimal point. That is 2.2f means 2 floating point. Like if I give you 100 and the person wants to see the balance, I'm going to put $ before, and then I'm going to bring the balance that the person have, and I'm going to add 2 decimal point at the end, like 100.00. That's how I want to present it to you to look at it. Okay, that is internally, that's how I want to build it, so that when you look for it, you see the data like that. So this property now give you access to seeing the balance here. So in case we change this balance to some other variable, you don't have to worry about how to get the balance. As far as you are still using the get balance, the answer you will always be the same. You don't have to change your code. We will implement the changes internally. Okay, so this balance, the balance object, you want to have a way to set it. Like if you want to update the balance, or if you want to do anything to the balance, okay, you get the information. But if okay, people can update the balance. So we have that particular variable object, a way to update it, and that is called you call it by the name of that object, the balance dot setter. Okay, that's how you put it. Add the name of the one you are calling here, balance, and then dot setter. The balance, this balance setter. You say dot setter. You have to put the dot setter before it. It means that the dot setter is what is going to be able to change that object in memory when you create this property. Okay, this property. This is what is going to be able to update its value. Okay, you see the name dot setter. Okay, then it has to be the same name. Okay, these names have to be the same, and then you put the dot setter. Then you define how to do it. Okay, how do you set it? So define balance. So this is a method. It says self, like self instance, and then let's say you have a new value to update the the balance. So for example, so I can do validation now and say, hey, before you update the balance, I check to see if the price, the value you are providing is less than zero. If it's less than zero, I say, hey, you cannot update the balance to zero, to negative, right? If not, that means that the value is zero and above. Then I am going to update this balance variable with the latest, with the value that you're providing for me. So this has given me a safeguard to prevent people to directly just update the dash underscore balance value directly. I have created a way that actually control how to update it. So this is very powerful. It provides validation directly into how your variables are going to be updated by other people. Okay, now we talk about the social security, right? This social security, we say it is private data, right? It's private data. We can give people access to read it. So yeah, so we can access a property, and the variable name self, and if they call it, this is just the getter, but we don't want to provide a way for people to update it. So we will not provide a way for you to update the social security. I mean, it's just a scenario we are saying. So if you call this social security, you call this, we will return for you this underscore double underscore social security number. We will give that back to you. So let's see this. So we have this our bank account. So we have our bank account class with all these things defined on it. So if I want to now create a bank account, it says the constructor says I need to give the balance and the social security. So look at it. So I give balance is 100, and then this is the social security. Now look at it. If I say I want to print the account dot balance, this balance here, okay, this balance here, the balance here is calling this property, this one here, property balance, and then it's going. What did it print? It print I put that, yeah. It print what? What did it print? 100, yeah. 100. You see, I entered 100 like this, but because I said this property balance issue, this issue return the amount and then two decimal places. So now I get 100 dot that. Okay. Now you can still access the underscore balance, the instance variable. This you can access it. Okay, but if you are accessing this, it's not recommended. That's what I say. Yes, it's protected because we want you to use this property to get it. If you are directly accessing it like this and we change this variable to something else, your code is going to break. That is why you should not be accessing the internal use variables for the function directly. Instead, use the add property, the property way to retrieve it to get that data. Okay. Now look at this. I take account dot balance equals 200. Okay. What happened? I'm setting the balance to 200, right? So I'm setting the balance. The balance here. Okay. Once I call this and I say it's equal to 200, you see that I call it as equal to. I just say equal to, right? Now look at it. Account balance works. If I say account dot balance equals negative 50, you see balance cannot be negative because this what the account, you see the property says setting the balance, right? You say if value is less than zero, it's going to print this error. If not, it's going to now update the balance. So first one works fine because it's greater than zero. And then next one is negative. You see, the balance cannot be negative because it's using the setter to determine when to update the balance. Okay, so you see, so you have built validation directly using that. Okay, okay, yeah, using the property for the setter, right? Okay, you build validation directly in there. Okay, now let's talk about the private social security. Okay, let's see this. So now, if for social security one with the double underscore, right? If you should print, if you say, hey, even though they say that class is private, I'm directly going to print it. Okay, I want to get a value. You get an error. You get an error because what? It says bank account object has no attribute this. You see, even though the social security is over there, when you directly want to, you see this is here, it has, you see this one here, when you're directly trying to call this to get a value, it says it doesn't have the attribute. He said this will accessing the private variable using name. Okay, he said this object has no attribute. That's a social security number. Meanwhile, the social security number is there because this is protected when it's like this. But there is a way you can get it. Okay, that way is you have to say underscore the class name, okay, before the double underscore social security number. And this way of accessing a private internal what variable is called a name mangling. Name mangling. You are giving underscore the class name before the two underscore whatever variable. It is not recommended. Yeah, it is not recommended to be doing this. So if we now print this, you see, now we can see the social security. This is not recommended. The best way recommended is to use the method for getting the social security. This one, the property for getting it, so that you go by this method. Okay, so if you just say account the social security, that is the you're calling that method, directly you get it. This is not recommended because you are directly saying, hey, you want to directly go and access that, and it's not recommended to be doing that. You should access it using the add property. Okay. Okay, so the benefit of using the at property, so you will see we are using it. What it does is it does validation. It stops you from giving bad data. Remember when we are giving negative, it check to see what value. Otherwise, anybody can just update the account to negative. Okay, the balance to negative. So the add property give you a process to make sure you build data validation into your update. And read only access with the add property, you can have a particular variable, have only a getter, then there's no setter, you can update it. All right. So the flexibility is also there, right? You can change the internal variables or the private variables into anything. But with the add property, the person will always just be calling that particular property, and they don't care how it's working behind the scene, how the wires are working behind the remote or anything like that. They are just pressing the button to go to the next to raise the TV volume up. So that's the really good property way to actually build your classes. So there are a lot of things about classes. So we go to the next one. It's called inheritance. So what is inheritance? So like we have take about the family tree. We have parents, they have some attributes, things about them, and when they have kids, the kids take some of the things from their parents. So I got this from my mother. You know, most of the things probably you got a lot of DNA, looks, and stuff like that from your parent. So it's in programming the same thing. So inheritance allows you to create a parent class. So we have a class that is a general class. Then you create child classes, okay, which is going to be just a very specific version, and these child classes will inherit from the parent class, all the features of the parent. Okay, you don't have to retype all the features for the child class. It's going to inherit everything that the parent have. Okay, so think about it like this. Okay, the parent class is the super class and the child class is the subclass. Okay, so the general category like animals. Okay, general animals, and then we have a specific version of animals: a dog, a cat. Yeah, human beings are also animal. So the bigger class is the parent, and then any specific version is the child. So classes, Python classes have the same attributes. So let's look at it. We have the animal class, okay? So we say animals, okay, we define, okay, they can breathe. Okay, that is something we define for the general animal. Say, they can breathe and then they are breathe, just say inhale, exhale. Okay, that's what all animals can do. That's the general class. Okay, now I want to create a dog class that inherits from the animal class. So this is how I write it, class dog. Then I put the animal into the bracket here. See, this animal, I put it into this closing bracket. This is telling that this class dog is inheriting everything from this animal class. Okay? So the dog will inherit from the animal. And now if when I go into the dog class here, I can whatever I want my dog class to do, but it will inherit everything that is already in the animal class. Okay, so like for this dog class, I say, okay, if I'm creating an instance of my dog class, I need a name, okay, for my dog class, okay, to hold the name of the dog, which is in my instance variable name, okay. And this my dog class has its own method called back. And when you call the back on the self, the dog self, it will print wolf. It will just say wolf, like dog barking wolf. Yes. So then I have another class called cat. A cat class that also inherits from animal. Okay? It's also inherit everything from the animal. And then in its name, it also have an initial when you're creating a class. You say, hey, you give a name, then I'll store it in your name variable. And it also has its own method saying meow. And when you call that meow, it just prints meow. So all these two, dog and cat, inherit the animal class. Okay, so internally they all have this breath, yeah. Internally they all have it in them. Okay, because they inherited everything from their parents. So let's check how that works. Okay, so we define them over here. Now, so this is one dog, body, dog. Okay, let's run that. Body, the name to create a dog. If you print body dot name, yeah, this is dog body. Okay, now we say body dot breathe, right? It's inherit this from the parent because it's a dog and is an animal, so it's able to inherit the breathe. So when you say breathe, you say inhale and exhale. Okay, body dot back, excuse me, is in the chart, it's in the chart. So here you say back or say wolf. See, this is in the chart. So it's able to say wolf because it's part of this dog class. Okay, so so let's create another instance of a cat, the cat class. So I say, hey, Whiskers is the cat and the name is Whiskers. And I print the name is Whiskers. And I say Whiskers.breathe. Yeah, this is also inheriting it from the animal class. And then there's a specific method here, meow. And then when I call it Whiskers.meow, it says meow. So you see that, they are able to inherit things from the parent and then they add their own things and then do different things with it. That is inheritance, a very important concept. All right, polymorphism. Polymorphism. Poly means many, morphism means shape. So many shapes. So let's give the example, right? You see the remote, your remote, that's what you say, your remote. One remote, you can play music, you press on it, you play music, the music player, you play music, you turn it to the DVD player, and then it start playing the movie. So the same thing is doing multiple things. The play button is doing multiple things, in different things. So in programming, it means that a class can have a method with exact the same name, but they will act differently based on the class that is based on the object that is applied to. Okay, so let's go to the examples we always work. So we have an animal class, right? This animal class define speak at the animal level. You say you cannot, this one we are saying you cannot call speak just directly from the animal class, because every class that inherit from it, they will implement their own way of speaking. So if I say a cat, okay, this is a cat, inherits animal, that is defining its own speak, okay? The way I'm going to speak, return meow. Okay, that is how I speak as a cat. Okay, this is the method defined at the animal level, but I am overriding and say, hey, this is how I speak. I say meow. Okay, when have a dog that inherit from the animal class, the dog speak, it says, hey, return wolf. So you see that the same speak when it comes to a cat, it's saying meow. When it comes to dog, it's saying wolf. So it's the same method name we are calling, and they're all having different things that you see based on the object. So this is what we call polymorphism. Okay, polymorphism. Okay, all right. So this is the cat. Okay, you created a cat, whiskers cat, and then body. So you see that it's not like when you create a class, you always have to have an innate class, the innate method. It's not like you have to always have this, right? If your cat doesn't need anything to create an instance, then you don't have that. Okay, you don't have the init. But if the class needs something to create an instance of init, then you need to pass in the variables that init. Okay, that's all. That's it. So in this case, you see, we create a cat and the dog. We didn't have any init or whatever it is in this class, and then we create a copy of the whiskers dog. We didn't pass anything because there's no init asking us to provide any parameter to create whiskers, and then the same for bodies. Okay, so when say whiskers dot speak, is just a meow, because that's the implementation of the this parent class for speak. Okay, so that is polymorphism. Okay, different classes. Okay, another thing about polymorphism is the use of the super, or yeah, super, yeah, super. Is it super? This should be super. That's the name. Has to be supposed to be split. So we say let's another class robot, and the class robot has defined a method work. Okay, instance method work, and then it just print robot is starting up. Now, I want to create another type of robot called cleaning robot. Okay, cleaning robot, it inherits from robot, so it has this particular method as far as it inherit. Okay, now this method work, this robot cleaning robot is going to override this in a way for itself, in a different. You want to do something about this, it just doesn't want it to be just this. It wants to say that I want to add something to my to that method, whatever it's doing. So it calls it define the work method again, and to access whatever this method is doing, it will say super, okay, dot the name of the method in the class here. Okay, so super dot work. Okay, so it's going to be whatever is happening in the parent is going to do it here first, then it will do its own of whatever it wants to do, cleaning the floor. Okay, so if you take this, Roomba equals cleaning robot and Roomba.work, you see that it calls the starting robot is starting, which is coming from here, by using super.work. Then after that, you say cleaning the floors, which is here. Okay, all right, so let's go to the next topic. The next topic is composition and then inheritance. Okay, all right, so we look at inheritance. Okay, we look at inheritance where we say a class is there, you create a child class to inherit everything from the class. That is inheritance. So when you inherit everything, good or bad, you get everything. But composition, okay, is another concept. So composition is where you build a class out of other classes. Instead of inheriting from them, you are not inheriting, you are building a new class, but you are not inheriting from all the classes. You are going to build some, you're going to have smaller component that you are taking only some the component, but you are not inheriting the entire class. Okay, you have multiple classes, you bring them together to use. So for example, right, that's what it is. A car, let's say there's a class for engine, a class for battery. You create a car, you don't say a car inherits from the battery and then the engine. No, you say a car, then you have a component for engine, you have a component for the battery. Okay, it's not so the relationship is very good to look at it. So in inheritance, okay, for inheritance is a relationship. So you say a car is a vehicle. So vehicle is the big let's say the vehicle is a big class, and then a car inherits everything from the vehicle. That's inheritance. Okay, but composition. Okay, a car has an engine. That's the relationship. A car has a battery. A car has a time. So composition is the composition. We say composition. The relationship is has a relationship. Inheritance is a relationship. So for composition, help you build objects by combining simpler ones. Okay, and you can change the behavior of the complex car by just changing the component. So like cars, for example, battery issue, you go and fix battery. Engine issue, you go and fix engine. And so it is actually recommended when you are building classes, instead of doing inheritance, to do composition. Okay, don't inherit everything, rather do composition. So let's go and see an example. Okay, so we have the engine. Okay, the engine class. Okay, engine class has a method start, and it just return vroom. Yes. Then another class, battery, it has a method charge. It just return charging. So these are separate classes on their own, smaller classes. Okay, now I want to create a car class. I don't want it to inherit engine, battery, no. Why? So I'm not putting in here like, oh, inherit, because if you want to inherit, then you have to put the names here, right? Engine, battery, all of them together. You can inherit from multiple classes. Yeah, that's also possible. Yeah, you can do this, but we don't want to inherit. Okay, we want to have the car, and instead we will create objects that have these compositions, this particular component. So we say my car. So this is my car. Dev in itself. This dev in itself. Okay. Then I say, okay, I'm having an engine, and that engine is pointing to this class. Okay, the engine class over here, that component. And then I'm having a battery, and that battery is also pointing to this battery class. So this is composition. Okay, it's taking this, it's not inheriting them. Okay, now inside my own car, okay, in my own car, when I want to start, okay, when I want to start the car, I just go and call this object I have created from engine, okay, self.engine dot start. So in classes, you put the object name dot the method name. That's how you access it, right? So engine dot start. So this engine is this. The dot start here is referring to this engine start over here. So we are delegation. So the car is delegates the start action to its engine. So and this start will be calling the engine start over there. Okay, and I define another charge for a car, and I say the battery dot charge. So it will go and delegate the action to the battery, and then what is the charge? So, okay, and then if we do this, if we so now I have a car. I've created a one car instance, a Benz, and I say Benz dot start. It's a vroom. Okay, this is the car now. It's a vroom, and what did that vroom come from? From this engine class. And I say charge. It's a charging. Okay, charging, which is coming from the battery charger. So we have created a composition of different classes to put into the car class. So that is composition, and it is actually recommended to go with composition than inheritance, because in inheritance you inherit everything. Even if you are not using it, you inherit it. Even like your parents, if you inherit the disease, you don't want the disease, you still have to inherit. So that's the difference between those concepts. And this is a very this is the highest object we will be handling most of the time. In so everything we are building at this time, we have a class, and then we define the methods, the variables, and everything, and then we will be able to use that object, in defining the stuff. So here is the quiz for this lecture. You are going to implement a bank account a class that is a bank account, okay, and it will have the method to deposit an amount, a method to withdraw an amount, and also it will have a balance property, okay, a balance property that will guide people from. So like for example, you should add simple overdraft protection, so that if somebody is trying to take the money, they want to withdraw something, you need to make sure that they are not overdrawing their account, okay. So you're going to implement a bank account like that. Now, another one is you're going to create a student class, okay? And the student class will store the student name and the grades, which is a list. And then you create a method to add grades to that list, and then you'll be able to find average, okay? And you can have a method to see if it's passing, okay? And the minimum average should be 60, okay? Should be 60. So these are all methods for this class, okay? It's passing, minimum average 60. So when you call this method, it will tell you that this student has passed or is passing the grade or not, because it has a list of grades. You can use the average to find the average for the list of grades, and then it's passing to check to see if the student is passing the grade or not, okay. And the condition is that the minimum average for passing is 60. So if you check and then their minimum average is not 60, then they are failing, okay. That's one. The third one, we are going to create a thermostat class, okay. It will prevent the temperature from being set below 10 and above 36 degrees Celsius. So we want to see how you handle this one to create that particular class. Okay, then the fourth one is we want to create a library and a book class, okay. The library class and then the book class, okay. We don't want to inherit from a book so the book is there, and then we are creating a library. We don't want to inherit from the book class. Instead, we want to have the library contain a list of book objects, okay. Like we talk about composition, it will have book objects in it. So we have books objects, so we can add methods in the library, so that in the library class that can add books to the books object, okay. You can add books to the book object, and then we have another method which can show all the books we have in the library, okay. So this is a pretty nice quiz to see how you understand this side of object-oriented programming. So thank you for watching this lecture. Thank you.